Let's just dive right into this explainer and see what happens when a highly efficient challenger steps up to take on the smartest AI model in the world. We are looking at what could honestly be a massive shift in the tech landscape today, and the results of this particular Opus 5 versus Fable 5 matchup are, without a doubt, going to completely change how we think about artificial intelligence moving forward.
So we're putting Anthropic's reigning premium champion, Fable 5, head-to-head against their brand new, highly cost-effective release, Opus 5. You know, for a long time, the golden rule in the tech space has been pretty simple. If you want top-tier, maximum intelligence, you have to pay top-tier, maximum prices, right? But with the incredible pace of development we're seeing right now, we really have to ask if that rule even applies anymore. Can a vastly cheaper, more streamlined AI actually dethrone a massive flagship model?
Section 1. Specs and Cost Breakdown. Let's look at how these models stack up. Anthropic is playing a really fascinating game here. As a direct response to the massive rise of those highly competitive Chinese open-source models taking over the market, Anthropic aggressively positioned Opus 5.0. It cost nearly half the price of their flagship Fable 5. But here is the absolute kicker. It matches the exact cost of their older Opus 4.8 model. Think about that. Users are getting a massive generational upgrade in computing power for literally zero extra cost.
Now, the crucial point is this tiny little number. When pushed to its absolute maximum effort on a major coding benchmark, Opus 5 came within just half a percentage point of Fable 5's max score. 0.5%. You're getting nearly identical intelligence for a fraction of the cost. But, you know, benchmarks on paper are one thing. We really need to see what this actually looks like when the AI gets out of the lab and starts building something real.
Section 2. Real-world tests and simulation capabilities. Let's see them in action. To see what that razor-thin intelligence gap actually looks like in practice, we have to stress test their real-world engineering chops. And wow, Opus 5 didn't just pass the basics, its autonomous feats are staggering. It built a fully interactive 360-degree 3D wind tunnel right inside a single browser tab. You can rotate the car, watch the airstreams react in real time, and even flip the car 180 degrees to watch the airflow instantly flip with it. You can even drop a 3D character in there and the air reacts dynamically to it. It also built an interactive biology cell that lets you peel it apart layer by layer. But the most incredible part, when given a drawing of a machine to rebuild in 3D, the model realized it couldn't open the image prompt. So what did it do? It seamlessly coded its very own vision tool just to study the drawing.
This brilliantly illustrates the massive leap in autonomous problem-solving we're witnessing right now. It didn't just use a pre-existing tool, it built the exact tool it needed on the fly. And this is entirely driven by vastly upgraded alignment and safety protocols. This new alignment allows Opus 5 to constantly check its own work, recognize a roadblock, and just continuously loop back until the task actually succeeds. It is a completely different level of autonomy.
Section 3. The Nitro Arena Test. It's time for some head-to-head coding. We threw these heavyweight models into the ring together with one highly detailed prompt: build a 3D Rocket League-style car soccer game entirely from scratch. The requirements were realistic ball physics, the ability to drive up curved walls, boost and jump mechanics, a starry skybox, metallic goals, and atmospheric details like crowd cheers when you score. No extra hand-holding at all, just one detailed prompt to see who could build the most functional and visually impressive browser game.
When the results came back, the difference was honestly staggering. Fable 5, the reigning champion, went first, and to its credit, generated a solid, fully playable game right away. The countdown worked, the core loop was solid, and you could hear the crowd. But the stadium was pretty plain, and the car felt a bit floaty. Then, Opus 5 stepped up and absolutely blew Fable 5 out of the water. The difference was immediate. Opus 5 delivered a realistic-looking car, a beautiful starry sky above, sharp reflections on the floor, true ball weight, and flawless physics that allowed you to seamlessly drive right up those curved walls and blast the ball into the net.
Now, to remove any human bias from the equation, a rival AI, GPT 5.6 Sol, was brought in as a blind judge to analyze and score both builds out of 100. It awarded Opus 5 the crown with a 91, praising its realistic physics and lighting. Fable 5 came in second with an 86 for its solid gameplay loop. But hilariously, when GPT 5.6 Sol was asked to judge its own prototype, which was basically just a plain grid floor with glowing shapes, it put itself in dead last with an 82, freely admitting that its own game was visually underdeveloped.
Section 4. The Tumble Rush Test. Let's look at the obstacle course challenge.
Just to prove that round 1 wasn't a fluke, the models were tested again. This time we asked for bean characters racing past swinging gates and spinning hazards, a real obstacle course. Once again, Opus 5 took an easy win, delivering a vibrant, colorful course with a pre-race countdown, energetic music, and, most impressively, perfectly working AI opponents racing right alongside you. When we looked at the competition from GPT 5.6 Sol, things just completely fell apart. It was a shaky, laggy, unstable mess where the character literally slid right off the platform and the game constantly reset itself. Opus 5 is clearly, undeniably dominating these complex, agentic coding tasks.
Section 5. A new prompting era and context engineering.
But here's the catch. To get these kinds of heavyweight, dynamic results out of Opus 5, you have to completely change how you talk to the AI. The old way of getting AI to work for you meant writing the perfect, highly restrictive prompt. Well, Anthropic just made that approach completely obsolete. The new context engineering workflow for the Claude 5 generation requires stripping out over 80% of your hard-coded rules. Instead of stuffing your prompts with rigid instructions, you just let the model think freely. You can literally turn Anthropic's official Opus 5 guide into an automated skill where the AI learns a task just by watching you do it once, quietly setting the rules for conciseness and style in the background. It performs vastly better without those old massive lists of restrictions holding it back.
Which brings us to a massive shift in the tech landscape that we all need to consider. We just saw a model that cost half the price entirely outperform a flagship premium model in complex, real-world physics and coding tasks. If an efficient, heavily aligned model can build its own tools and generate flawless 3D simulations from a single prompt, you really have to ask, is the era of the ultra-expensive, massive AI model already over? I highly recommend diving into the source material to start building your own 3D simulations tonight and really testing the limits of what Opus 5 can do for you. Thanks for joining me on this explainer, and keep exploring.